Welcome to Programming Rainbow. In this video, we will continue on the series of Minesweeper in C and SDL3. So this is the 8th video. If you would like to follow along with this series, you can go to github.com, and this will be Programming Rainbow /Minesweeper C SDL3. You can git clone that repository, moves inside the directory, and open it up with whatever editor you would like. I'm just going to show you the final project real quick. So this is Minesweeper. We can make it different sizes, both as a display size and as different actual amounts. And we can change the difficulty level by adding more mines. And we have different themes. I'm just going to end the game real quick on the wrong click here. And we can see these themes here. We have the two Italian themes. We also have the monochrome Italian theme and all the different kind of themes that like Windows 3.1 to Windows XP. Okay, and for the most part, it's just like the game. So the little face changes when you click down, and then when I release somewhere, that's what happens. So that's the game. And in the last video, we basically had everything displayed, and we also added the mines to the backboard and the numbers. So let's just compile that real quick, and we'll show it. So we have this where we have the actual mines being drawn now, and we have the numbers in place, but we're looking at the backboard, not the front board. So in this video, we're going to show the front board again, and this time we're actually going to be taking input from the mouse, both the left and right buttons. So there's a lot of information happening in this one. And we are going to be processing that to reveal what is underneath it. And we're also going to do the algorithm that shows when it's a 0, we need to actually uncover more spots. So we're going to be using linked lists and things like that. There's a lot of stuff to cover in this video. Try to condense it down, but basically the mouse clicks and stuff, it ends up being a lot of information. I might be moving through some of this a little bit quickly, so if you have questions, just ask them in the bottom of the video, and I will try to answer those best I can. Okay, so one of the first things I want to do is I've been using a left and top offset for the board. And that's fine, but I actually need the right side and the bottom of the board as well, because I need to know if my mouse click happened on the board. So I'm going to change this, where is it? This top offset, left offset. I'm going to turn this into a rectangle. That'll work better for me. So I'm going to basically remove those from the board H. And I'm also processing the right and the mouse buttons. And I'm going to be processing when the down click happens and when the release of the click happens. In my original code, I have just the board has been pressed Boolean, but this time I'm going to actually separate the right and the left, because I kind of imagined that this would get you into situations where if you clicked one mouse button down and it thought it was correct, and then you click the right mouse button down and then release the left, you might get into weird situations. So I'm going to process the right and the left mouse clicks separately. So those will be two booleans. So that's basically, I'm just going to add here an frect. So SDL, this is going to take the place of these two, top offset and the left offset. It's still going to be there. The top and the left offset is basically the top of the board and the left side of the board, but I also want the right side of the board and the bottom of the board. So these are just going to be encoded into the frect. I'm just going to call it rect. And then I'm just going to have these two bools. Basically, I want to know if I've pressed down, if it was a real press on the board. And then when I release, I need to know if it was previously pressed on the board, because you could press down your mouse button off screen somewhere, pull your mouse onto the screen and then release. I've kind of been checking some of this stuff. Maybe not every situation, but most of it. So left, we'll say left pressed. And right pressed. And we're going to be using a linked list as well, because let me just pull up. I'm going to do the final code again. And so when I click somewhere, sometimes it reveals what's under the board, but sometimes it reveals a whole bunch of squares, right? Let me see if so right here, it just did that. So what happens is it wants to reveal a number, but if it reveals like basically the 0 position where it's not a 0, it's just nothing, like I clicked right here. Let's see if I can make that bigger. Yeah. So I clicked right here, and there's no number. So not only does it reveal this spot, but it starts looking around it. It looks around all the ones touching it and says, okay, I want to reveal those too. So basically, if it's ever a 0 spot, it's going to reveal all the ones around it. So, and then this one is a 0 spots too, so it needs to reveal all the ones around this. And then this is a 0 spot. You get it? When it gets up here, this is a 1 spot. It just reveals the 1. It doesn't reveal what's around it. So we need some kind of way to keep track of this. So what I've done, I mean, you could do this recursively, but what I've done is created a linked list. And every time, like when I clicked here, it not only needs to uncover all of these, but it needs to add this to a linked list to uncover all the ones around it, right? And this one and this one. So while I'm processing this one, it can just add this to a linked list, and then later on it processes that one, and this one will get added to the linked list. And so it's able to, I can keep processing the one I'm looking at, the squares around the one I'm looking at, but I can add to like a queue of what I need to process next if another one of them is empty. So basically, I'm going to be pushing and popping off of a linked list, just a very simple one that's just a row and column and a pointer to next. Since we don't have like the dynamic array sizes in C, this is just a simple way to do it, just a basic linked list. So this is what it's going to look like. It's going to be struct. And I actually originally had this two structs. Well, I'll show it here. So we'll say node. And all this is a single linked list. It's just a node pointed to next. So I'm always dealing with the head of the linked list. So basically, this node can also point to another node, right? And so if there was one node and it was also pointing to another node, the first node would be the head, and so on and so forth. So I'm going to use this linked list. Basically, this is going to allow me to have a dynamic list. You know, I can basically, you know, if I'm looking at say 1 and when I process everything around it, while I'm doing that, say 1 2 is also empty, I can tell it to point to 1 2. And when I'm done processing this, I can delete this and now go look at 1 2 and carry it. But if I can just keep adding and adding and adding onto it. I could have 20 things in this list, but I'm going to process whatever's at the head, pop the head off the list. Then I'm going to process the next one, process the next one. Yeah, basically. So we'll kind of see it as it goes here. But the only thing this is holding is the rows and the columns. So we're going to say int row and int column. So that's all that this structure is holding right here. And I did have basically 2 structures. And it was like this right here. And it was called pause. And it just was missing this. So when I popped one off, I could, I need to put that here. So when I popped one off, I could just get the coordinates, but I thought, well, this is kind of redundant because I could just set this to null and it's fine. So yeah, I've condensed this down to just one struct. So that's a data structure we're going to be using for the linked list. Here's our rect. Here's our if left mouse button was pressed, you know, if it was considered a good press, and if the right button was pressed. So that's all we need to do right now in the header file. The C file is going to complain now because we have changed these. Wait, did it? So I need to remove these 2. It's going to complain when I remove these 2. I'm going to set up the rect here. And this left is actually the x of the rect, right? So we can just say rect.x. That's the left, right? This top is actually y, right? But I'm going to put them in the order that they appear in the rectangle. So and now we need to do the width and the height. Rect.w. And this is going to be the columns times the size of the piece, and we're going to add the x to it. This position, basically, the width. So this is not a proper rectangle. So what I'm doing with this rectangle, I'm just using the positions. I'm just using it as this is right and this is left. So it's not really correct. If you think about a rectangle, this should be the width of the rectangle, but that's not what I'm actually doing. I'm setting this as the right side of the rectangle, and I'm setting this W should be the width, but I'm not setting it as the width. I'm setting it as the right side of the rectangle, which is the width plus the left side, because that's all I'm really doing with it. I'm checking bounds. Let me show you in the what I'm talking about here. I've changed the code, so we'll run the original one. So what I'm talking about right here is this spot here, the board right here, is my rect. Basically, I want to know if my mouse if I clicked right here, that's in the border, not the board. And if I click over here again, I'm in the border, not the board. Or if I click over here off the screen, like I need to know that I'm clicked in the board. So what I've done here is normally this could be like 200 pixels down, which would be my Y. And my X would be like, say, 50 pixels in. I'm just making up numbers here, but let's say it's 50 by 100. This now would be the width. So to get the right side, I would actually add the width to the left side. But I don't want to do that. I'm lazy. I'm only doing one thing with this rectangle. So what I'm going to do is the X is going to be the right side, and W is not actually the width. It's not the width from here to here. It's the entire, you know what I mean? It's the X plus the width together, because that's all I'm doing with it. All I'm doing is checking bounds. So I've just held it inside of a rect, but the width is not really width. It's actually right side. And the same with the height. The height is not really height. It's actually the bottom side of the rectangle. So you can think of it as height plus the Y offset. That's just because I just want to know if the click happened in the board. So I'm just using the rectangle that way. So I don't have to calculate over and over again where the bottom of the rect is. I'm just going to make height be the bottom of the rect, and I'm going to make width be the right side of the rect, if that makes sense. And we have to cast this to a float. So what I'm going to do is I'm going to take the B columns, and I'm going to multiply it by the piece size, which is right here. We've already calculated that. Right? So that actually gives me the real width of the board. But like, again, I didn't actually want the width. I want the right side of the board. So immediately I'm going to add in the rect.x. So if this was really width, I would leave this part off here, but then I would have to calculate it down later in my code. So I'm just putting it here automatically. So this is actually now not W, but right side. And the same with the height. I'm going to do the same thing. So rows times piece size again. And this one is going to be plus Y. Okay, so that's going to give us basically something that I can check the bounds on. So I'm going to have two errors right now. And what it is down here, because this is looking for top and left. So top is now rect Y. And left is rect X. So this should work. Let's just try it real quick. So if you don't know, I'm editing the code in the source directory right now, and my makefile automatically looks at the source directory, and unless I specifically tell it not to. So when I'm trying to show you the final project, I'm directing it toward the video 10 folder. But what we're actually editing right here is the source directory. So everything looks fine. The board is still being drawn correctly. So it looks like the replacement worked. Now we basically need to start working on like processing clicks. So what's going to happen is I have a mouse click down. Let me show you again the final project to show this. So if I click the mouse down up here, I don't want it to do anything. If I'm still holding the mouse down, I've clicked it down here. I'm clicking it, I'm holding the mouse down, and now I'm releasing it on the board. And that actually shouldn't happen. Let me do that again. Maybe that was and my final code is not necessarily what we're coding now. I've changed some stuff. I'm going to click down here and release. Yeah, see, down and release. Now, if I click down here, see his face changed. I can go up here and release and nothing's going to happen. So I need to know if the down click is relevant and the up click. Okay, so the first thing I'm going to do is check the down click. The down click, nothing really happens, but it's like preparing it. Down here, I'm going to go down above draw. So I'm going to call this board mouse down. Board mouse down. And right away we need the board, so that's just B. But when we process mouse inputs in SDL3, there's an X and a Y that are both floats. So that's fine. We're going to keep those. So in events, the way that we deal with mouse events is just like the way that we deal with other events. It's like the quit event, the keyboard event. So there's an event. If we go down here, it's called mouse button event. If we go down, let's see here, down here, mouse button down and mouse button up. So right here, if we're looking at this is going to be called button. So this would be event.button. And if we open this up, which I've already have opened up over here, inside of here we have an X and a Y float. This will be the coordinates relative to the screen, the window that you have open, the SDL window. That will be the X and the Y coordinates. And then there's another one here it's a uint8 called button. And that's a little confusing that they just put uint8 here. But if we want to decode what this is, it's actually here in SDL mouse button flags. There is SDL button left and SDL button right are the two that I'm going to be using. So we can just test that event.button.button because this one is button just for the mouse, basically the mouse click. And then inside of that, there's a button for the left and the right. So it would be event.button.button to find out what it is, or event.button.x or .y. So this is to do with mouse clicks. So it's not necessarily mouse movements, but mouse clicks. But we do want to know if it was the left button or the right button that was clicked down. And we do want to know the X and the Y coordinate of that. So in the game, it already knows this signature because I've been, typing it in the other ones. So that's why it auto-completed. But we're going to see later on when we process in events, when we process a mouse click, we're going to have an X and a Y position for that mouse, and we're going to have button information. So I'm going to pass the X and the Y and the button into this function to process it. Since I've separated out the left and the mouse clicks because I want to know which one is happening because I'm doing different things with them, I'm going to automatically set whatever button I've clicked to false. And then in my processing of this button, if it is true, I'm going to set it to true. So basically, if it was already true somehow prior to this event, and now I've clicked like in the border, I want to disable that button. If I have a button pressed that is a press down, and it's valid, and somehow I unclick off the screen somewhere and it still thinks I have a valid down press or something like that, and then I go to press down again, I don't care about any past presses, so I'm going to reset that. I'm just going to basically set it to false immediately before I even process further. But since I'm separating out left and right presses, I need to know if it's a left or if it's a right press. This button that's sent in here, I didn't pull it up, but basically it can either be SDL button left or SDL button right, this uint8 right here. So I'm going to check that. So button left. So if it's a button left, I'm just going to set it to false immediately. I don't want to mess with the right button one. If there's already a right button happening somehow, this event specifically is looking at a left button. I'm gonna reset the left button to false and then keep processing it and seeing if I want it to be pressed or not. So left press is going to equal false. And I'm going to do the same thing to the right. If it's the right. And these are the bools that we set up earlier. Basically, if I've clicked the left mouse button and it's registered that as a click, I'm immediately going to set it to false. And I'm only going to set it to true if it is a valid click in the board somewhere. So what I need to do is also find out, is it in the board? So we do have that rectangle that we created. So I'm going to use that to make sure the click is happening in the board. So this is X. I'm checking the actual, so X and Y is going to be the actual number relative in the screen that we create. So it's not going to be relative to your actual monitor. It's relative to the window created by SDL. So I need to make sure that that is within the rectangle. So I'm going to say if it's bigger than or equal to b rect.x, and it's also x is smaller than b rect. I am doing the math here to check it. I am choosing x plus width. So I'm going to backtrack on what I did above for, well, no, we can just, yeah, because it is a little bit confusing. So this thing up here that I did a little bit confusing, since this is a rect, I'm just going to let this be width. So I'm not going to add this part in because I'm doing it down below. Because it is a little bit confusing because this is a rectangle for width and height. So this is the actual width and this is the actual height. So down here, I'm actually doing this. I'm taking the x plus the rect dot width, and that's going to give me the right side. And this is equal to or bigger, so that if let's say my rect starts at 10, I actually want 10 to count. But this one is the right side, and so I need it to be actually smaller than that. If it's smaller or equal to, it's going to be 1 pixel to the right too far. It'll be off by 1 pixel, which won't cause anything to crash, but it'll probably just allow you to be able to click 1 pixel past where you should be able to click. And I'm also going to check the Y the same way. So if Y is bigger or equal to b rect.y and Y is less than b rect.y plus b rect.height. So if this is all good, we're in the board, we have a good click, and we can keep processing. If this is not good, it's going to fall through. And we've already set it to false, so it's going to fall through and be a false, as in we're not counting it as a click. But since we are still good here, now I want to convert this actual X and Y coming in to rows and columns. So that's going to be different. Those are, I need to scale it inside the thing. I don't want the actual pixel position. I want the rows and columns. So we can index into the array. So int row equals, and I'm going to cast it to int. We need to act like the Y is the 0 So for the top, for rows, we need to act like y is our 0 position. So we're going to take y and we're going to subtract rect y, because if our rectangle started at, say, 10 pixels down and our y is at 10 pixels, so this is a valid click, that 10 pixels actually needs to be 0, because we don't care about the screen, we care about the board itself. So imagine this is our y right here. This is the board, and this is not the board. So right here, so say this is 150, right? Well, if I'm trying to figure out this is the 0 position for rows. So I don't need this information here. So if this is 150 and my mouse is at 155, I want my mouse to look like it's at 5, not 155, because this 150 here is not relevant to me. I'm looking at the board, not the border. So relative to the board, I'm going to take my position. I know I'm inside the board, and I'm going to subtract that, and then I'm going to do some dividing. So this right away is going to be y minus b rect y. So that's going to get us where we're basically looking at it relative to the board now, but we need to divide it by the size of the piece now. This piece size. So basically, if we were at 155 and our piece size is 10, well, it's going to say 5, and we're taking 5 divided by 10, which is 0, and we're in the 0 position if our size was 10. Okay, so if we were at 161 minus 150, that's going to give us 11, and we're at 11 divided by 10. Now we are in position 1 for rows. So that's what we're doing here. We're fixing our offset, and then we're dividing it by the size of our pieces to get an actual row. Then we're going to do the exact same thing for the column. And this is going to be x minus b rect dot x. And the same thing with the piece size. Now we have a row and a column. Now we want to deal with the right mouse button. I think is the easiest first. So I'm just going to do that one. I'm going to say if button, just like up above. SDL button right. And now what I want to do is when I right click on it, I want to set it, if it's not set, I want to set it to the next one. So if we look at our images here, imagine this is the standard image, which is 9. When we're looking at the front board and nothing has been clicked yet, the right clicking shifts between these 3 images right here. Nothing, we're indicating that we think it's a bomb, or we're indicating that we don't know what it is. And what these indications do is stop us from clicking. They don't actually change the game at all, but we can no longer left click when these 2 are. So it's just a helpful indicator to us, but it also prevents us. We can only press left click when we have this one shown. When we change it to these other 2, we can no longer left click for the game. So what's going to happen is if it's a 9, I'm going to let it be a 10. I'm going to let it be 11. And then when I right click on it again, I'm going to shift back to 9. So I want to loop through these 3 images here. This is when we're right clicking on a board piece that has not been shown yet. So it's unshown. We're indicating a bomb. We're indicating we don't know what it is. And then we're back to not indicating anything. And we can only left click when we're not indicating anything. So I'm going to check if it's a 9. Well, actually, I'm just going to check if it's in the range. If it's bigger than 8 and smaller than 12, which means it's 9, 10, or 11, I'm going to set the pressed to true. Basically, if it's a valid one, if it's 9, 10, or 11, I'm going to allow the press to be true, but nothing happens. So we're going to have B, and we're dealing with the front array. And we're indexing this array with our row and column that we've just created above. And I want this, whatever is in this row and column position to be bigger than 8. And also to be smaller than 12. Okay, so that's going to make sure that it's 9, 10, or 11. And if it is, I'm going to say the right press is true. So this is the only thing where it's going to be true. Anything else happens, if it's a right press, it's going to be false right away. It's going to be set to false up here. And this is the only happy path. All these things have to be true. And then this is set to true right here. This is not right here. I got this backwards, don't I? Yeah. That's the mouse down. And then when the mouse up happens, we have to kind of do the same thing. So I'm just going to take this signature up here. And this one, because we're going to be dealing with creating linked list, and we're dealing with calloc, and that could fail. So this is going to return a bool. And this is going to be mouse up. But the rest is the same right here. So I need to return true right away. Now, this one, I want to make sure that I'm processing the correct mouse button again. So up here, I've done this to process the mouse buttons. So I'm going to do something similar, but it's going to be a little bit larger. So I'm just going to yank that, put it here. What I want to know is if I'm doing a release of the right mouse button, yeah, if I'm processing that event, the right button has been released, I don't care if it was never set to true. So if it's never been set to true, I'm just going to exit this function right away. So let's go to the right one here. And if we are dealing with the right mouse button, the first thing I want to check is, was this true? So if this is true, sorry, if it's not true, if this is not something, which means it's nothing, if this is false, we're going to return true. The true on this means that the function is good, like something bad didn't happen. That's for the calloc. It's not returning that the button was pressed true. It's returning from the function because the function's done. And the true just means an error didn't occur. Nothing's being processed here. We're just getting out of this function. It needs to be a true because this bool here is looking for an error. And an error hasn't occurred. It's just this mouse processing click is not doing anything. So we don't need to go any further. Now, if it was set, if we do have a mouse down that was processed correctly, and now we're releasing it, so we did have a good mouse down, we want to set it to false, but we're going to keep processing it because the mouse is being released. We're saying that's been released, but we are going to keep going with it. So this will be the right pressed, and we'll say is false. If we're releasing, but it's false, we're just exiting. But if it is true, we're setting it to false, but we're going to keep going. We're not exiting the function. But this same exact thing is going to happen for left side as well, even though we're not doing anything left right now. Same thing's going to happen. So I'm going to process this the same way. That false shouldn't be here. So we're turning true, else we are going to set it to left. Be left pressed equals false. Okay, and then we keep processing. So if it was a left one and it's good to go, we're setting it to false and keep going. If it's a right one and we're good, we're setting it to false and we're keep going. It's like a latching thing. So this one, we're going to make sure that we are in the board as well, but I'm going to do it slightly differently because I don't want this is nested, you know? So I'm going to do it a little bit differently. I'm going to do the opposite. I'm to return early from it. I'm going to need all of this actually. So I'm just copying that up above, but I'm going to set it up differently. The reason why is because this if is nested in this if, and then other stuff will be more nested, and it's going to be too nested. So what I'm going to do is I'm going to do the reverse of this if right here. And I'm going to cause it to return out of this function if it's wrong. It's not an error, but it means I'm not processing it any further. So I need the logic of this to be backwards. So I'm looking for the get out of this function path, not the stay in this function path. So this one is if x is smaller, right? And now we need to change our logic to a logical or. And then this one is larger or equal. So I'm basically saying if x is smaller than this rect x, this is no good. I need to return out of this function. Or if x is bigger or equal to x plus x width, I need to get out of this function. It's no longer valid. Okay, I'm going to do the same thing with the y. So I'm changing the sign because this is the unhappy path. And I'm putting an or on it, not an and. And this one is needs to change to greater or equal to. And this will mean that I don't have this nested, I can pull these back now. So basically, if the button click was good, we're setting the button click to false. If we're not in range, now we're exiting the function. If we are still in range, we'll keep going. And now we are getting our rows and columns. So now we're going to keep going. And this one, we're just processing the right button. So I'll say if button equals SDL button right. So this is the one where we're setting what we're seeing. So remember over here, if we were here, we need to set it to here. If we're here, we need to set it to here. And if we're here, we need to set it back to here again. So it's pretty basic. Basically, we're checking if it's 11. So this is 9 right here. This is 10, and this is 11. So if it's already on 11, we need to set it to 9. For anything else, we're just going to increment it. And it's only a good process if the position's valid anyway. So front array, and we got row, column. I'm going to say if it's 11. If I know it's 11, we are going to be 9. That's a definite. And no, it needs to be in range. So yeah, I think I'm going to take where's the one in range? Right here, this one. So if it is this, we're just going to increment it. And we'll just plus on it. Let's see, I'm sure I've got something not right here. We need to close bracket here. Okay, so we have a minimal thing just to do right clicks right now. So we need to go into game and close this real quick. Well, actually, these need to be exposed. So what do we have here? We have down and up. Okay. So these need to be in the header file. This one's a bool. We're not using it as a bool just yet, but it will be very shortly. And that one's up. And now we have a problem. Since this is a bool and we're going to be doing it inside the event, that is going to change this to a bool. And in main, sorry, I'm kind of doing this backwards, but this now is a bool. And the happy path is just like this one above. So I'm not checking if it's an error, I'm checking if it's a success. Okay, so back into game. So what we're changing with those two right there is this bool. This one right here, the events has changed. That's what's going on here. So we have to do an if. This can fail. So we're doing, if this fails, we're going to return false. That's the failure. And then now this can return false. And this is the event. So it's going to complain up here. This also needs to be bool. And since we've changed this to a bool, I need to put a return true. Did I do that on the game as well? I'm going to put one here as well. Okay, so game event. And I need to change it on the prototype up here. Okay, now I think those are all correct, but we need to add in. So we have this new event, and I didn't pull up the page for it. It's very similar to the other ones, but we are getting an X and Y and a button out of it. This one is called SDL event mouse button down. Mouse button down. We're going to call that the board mouse down that we've added to the header. Right there, this one. So this right away is going to be G board. Okay. And now this X actually comes from event button X. So this G event, right? That's the event we're in. The event right here. And it's going to be called dot button dot X. And this is a float. So this was already taken a float. So this same thing is for the Y. Event button. This comes from SDL. And the button is called event button button. That should be correct on that. And then we do a break. So this is the mouse down, and this is fine because it's not, this one doesn't fail. The other one is the one that can fail. So I'm just going to yank that and do this, and it's going to be an up. This one's called an up. But this can fail. So I'm going to say if, and put a bang on it. So if it does fail, we are going to return false. And that's going to collapse down. This is going to return false out of this function. It's going to return false back to the other one. It all collapses down. Okay, let's see if there's enough stuff here to see something. And we are looking at the back board. We need to be looking at the front board. So I'm going to go back into board. And all we need to do is down where it's drawn, we need to change it to front. Front array. So I'm going to try the right click we got a bomb. And I right click again, we got a question mark, and I right click again. So if I click down here, it's not inside of the board. And so that doesn't get counted as an action. So the press, say if it's a right click right now, if I right click here, the right press toggle does not get set. The bool does not get set because that's not a valid position. If I do it here, it does get set. But then if I drag it up here and release it, nothing happens because the one that checks mouse up says, yes, it is toggled down. However, it says that that is correct, that the bool is in the right mode to run this function. But when we go to release it, it's also going to check the X and Y to see if it's within the bounding box again, and it's not. So that's why we have this code up here. When we're clicking down, we're basically disregarding whatever state that button was in for the if it's pressed down the bool. So no matter what happened previously, if we're going down, we're basically setting it to nothing now, and then we're going to choose within the same function if it's a valid position. And if it is valid, we are going to allow the toggle, the bool, to be set to true. And now this up basically says, for one, the very first thing that needs to happen is that bool has to be true. If that bool is not true, we exit immediately out of the function. The bool was false, we're still false, and nothing else gets processed. If it is true, we're going to set it to false, but we're going to allow it to continue processing, because no matter what happens at the end of this function, or however this function exits, it's going to be set to false because the key is being released. But we're going to allow continue processing. So then we're checking if we are within the bounding box again, but we're kind of doing it backwards. We're returning out of this function if we're not inside of the box. If we are still in this function afterwards, now we can set the row and the columns, and we can set whether it is just the up or the indicating that it could be a bomb or indicating a question mark. Either the 9, the 10, or the 11. If it's any of these, if it's bigger than 8, which is 9, and smaller than 12, which is 11, so if it's 9 to 11, we're going to advance it 1. If it is 11, though, we check that first, and we're going to set it back. So first thing we're doing, checking to see if it's 11, and we're going to set it to 9. If it's any other valid number, we're going to increment it. And that's all that we are doing in this one, basically just setting that right-click motion where it can be either the up one or the indicating bomb or indicating a question mark. So I know I just kind of covered it, but let me just really cover everything really quick. Since we had to change a couple things, border H, let's just go from the beginning. So border H, we have replaced our left and our top offsets with the rect now. And we are using it as a normal rect. I know initially I wasn't going to use it as a normal rect, but we are actually just using it as a normal rect now. And we are also having these two booleans for the right and left button pressed, so we know if we've counted a down press or not. And we have added this right here. This is for a linked list. This is going to be in the next video, so I will be explaining this in the next video. But basically, this is just a struct called node, which immediately has a pointer to its same kind of struct, that we're calling next. And it has an int row and an int column, so we'll be using it in the next video. The two functions, the first one where it's mouse down, nothing exciting is happening, so this is a void. This is just seeing if it's a valid down. The up, though, because we are going to be creating linked lists in the next one when we're using calc, this can fail, so we're checking the failure and we're passing it as a bool. So this is a bool. So since this is a bool, and this is being called from game, this function is being called from game events, right? Game events was void. But since we need to check to see if this failed or not, we're going to do an if statement on it, put the bang on it, and if it has returned false, we're just going to go ahead and return false from here. That means this function now needs to be bool instead of void. And also we're going to put down a return true down here. And we need to change the signature up here to bool. Now that's for game events, but game events gets called in game run, which means we have the same problem. Now we need to check game events, put a bang on it, do an if statement, return false. This needs to be changed to bool as well, and a return true down here. Now this function gets called from main. So main was just this function calling these side by side, but on this one, we're looking for the happy path. So this one, I'm not putting the exclamation mark or the bang. I'm not putting that on there because I'm not looking for the negative path. I'm looking for the good path because I've set exit failure up here. And if we ever get to the good path, I set exit success. Any other exit is failure, which is already set up here. So that's why this is I'm looking for the positive path to set exit success here. So we just put this in an if statement, basically, to change it from the prior code. So that kind of deals with the way that we've added in those errors, those returning of errors. And the error message gets created on the spot. But this returning a bool causes it to collapse all the way down and clean itself up correctly. So it always exits properly. So we're looking for the event of SDL event mouse down. There's also a mouse up. And within that, we have event button.x. That gives us our x position when the event happened. Here's button y, gives us our y position. Both of these are floats. And this event button, this is the uint8 that is telling us if it's a right mouse button click or a left mouse button click. So I'm passing these in, and if we look at one last time, if we look at the board H, the signature for the function, we'll see that we're passing the board in as a pointer, but we'll also have a float X, a float Y, and a uint8 as the button. And inside of the functions themselves, so here's one of them. We've passed this button in, and we are checking this button if it's an SDL button left. So that corresponds with right here, SDL button left or SDL button right. So we can compare that and know if that's the button we are pressing or not. So we have basically two new functions. Yeah, these are the two new functions. So right here, the reason why, like I said, if any down press is happening, we need to disregard any prior state that was existing because we're pressing down now. So no matter what happens, if it's a good press down or a bad press down, any prior pressing needs to be set to false. So we're checking we're setting the left press if this is a left action, if it's a right action, but we're not setting them both. You know, if I press the left key down, the left mouse button down, I don't want to mess up anything that is already pre-existing with the right mouse button. They're being handled separately, so I'm looking at them separately here. So whatever button was being used coming into this function, that's the one I'm setting to false immediately. And then I'm seeing if it's a valid, I'm checking the rows. And for this one, we're only looking at the right button. So it could be set to true here. Otherwise, it's going to be false if it fails anywhere here. This is just for the down click. For the up click, we're doing something similar. But like I said, we have to first see if this is valid. So if it's a left mouse button action, it has to already have been set to true. If it hasn't been set to true on the down, we're just leaving right away. If it's already false, we're just leaving right away. If it is true, we're doing the same thing we did above, where is now we're going to make this action be false, but we're going to continue processing it. You know, the next time that this function's run, it'll now be false. You know, so we're setting that to false. We're making sure that if we're outside of the bounds of that rectangle, that we are exiting this function, and the false will have already been set up here. If we are still good, we are getting our row and column position. And I've already explained this, but basically we're taking the Y, we're taking the offset, so it's relative to the board now, and we're dividing it by the piece size, and this gives us an index that we can index into the array. And this one we're just checking, like I said earlier, if it's 11, we're going to allow it to go back to 9. If it's anything else other than 11 within the range of 9 to 11, we're going to increment it. And since this could fail, right now we have no failure happening, but it will be in the next part of this video. We will be introducing something that can fail. But since it's a bool right now, we are returning true at the bottom of this. And all we did here on the board was we changed it from the last video. There was a back. We were looking at the back array. This time we're looking at the front array. So I hope you enjoyed that. I hope I explained it correctly. If you have any questions, just let me know in the comments, and I will see you in the next one.